This time we'll be looking at capacitance. We've been talking about electrical energy, electric field intensity, and so on. So those electrical energy are stored in a device called a capacitor. A capacitor has two plates. It is denoted by this as the positive plate and the negative plate. And in between these plates, it has an insulator. An insulator is that thing or that material that cannot conduct electricity. So in between this has an insulator called dielectric. Dielectric. We have the positive and the negative plate of the capacitor. So the ability of this device called capacitor to store and discharge electrical energy is called capacitance. And that is what we're looking at, capacitance. The ability of the system or the capacitor to store and discharge electrical energy is called capacitance. And mathematically, we can say that the quantity of charge is directly proportional to the potential difference, V. And what is potential difference? The work done in moving a unit charge from the source to a point is what we call potential difference. So we can say that Q is equal to CV, where C is a constant called capacitance. C is a constant called capacitance. And Q is the quantity of charge in coulomb. V is the potential difference in volts. So if you want to make C the subject, you can say that C is equal to Q all over V. So mathematically, we can define capacitance as the ratio of the charge per unit potential difference. And the unit of capacitance is farad. The unit of capacitance is farad, called F. So we have, for the practical aspect of the electronics, the components called the capacitors, they come in the smaller units. And those smaller units can be millifarad, which is equivalent to 10 raised to power minus 3 farad. We have microfarad. Let's write this, so that's millifarad, which is equivalent to 10 raised to power minus 3 farad. Then we'll have microfarad, which is equivalent to 10 raised to power minus 6 farad. Then we'll have nanofarad, farad, which is equivalent to 10 raised to power minus 9 farad. And then you have what we call the picofarad. Picofarad, which is equivalent to 10 raised to power minus 12 farads. So all these things are the units of capacitance. But if you are given in any of this unit mentioned, you can always calculate, convert to farad, since we have known the relationship. So the energy stored in the capacitor is given by U is equal to half CV squared, where C is the capacitance in farads and V is the potential difference in volts. So if you are given this and are asked to calculate the energy stored in a capacitor, this is the formula you use. So we have a problem here. If the capacitance of a capacitor is 50 farads, charged to potential difference of 100 volts, calculate the energy stored in it. So we need to write out the parameters. Capacitance is given as 50 farad and V is given as 100 volts. So the formula for the energy stored is U is equal to half CV squared. So we now substitute by saying that U is equal to half times 50 times 100. So you square this and U will be equal to half times 50 times 100 times 100 is 10,000. So 2 here 1, 2 here 25. So you have U now be equal to 25 times 10,000, which will give us 25, 250,000. Is that right? 250,000, which we can write as U equal to 250 times 10 raised to power 3. Or some people will write 25 times 10 raised to power 4. And some people will write 2.5 times 10 raised to power 5. All these answers are correct. And the unit is joules. Remember, what we are calculating is the energy stored. So it must be in joules. So in our next class, we'll look at how these capacitors are connected, series connection and parallel connection. Thank you.